Right, seems like that's ready. Right. Right, if you're on, put your name in the chat so I know who the hell I'm talking to. That always helps. Right, Numan, apparently you had some problems with this. So if you could give me an idea of where the problems were in the question. So your mum said it was finding the y. So let's have a look at that. Let's have a look at that before we go any further. The y part of the questions. Oh, so that's the bit where you're cancelling the y's. No, it's we cancel the x. You cancel the y's to get the x. Good. The y is the easy bit. All right, so let me demonstrate with an example, right? I'll do one of them from your homework. So that was 8x. Oh, that's horrible. Sorry. I washed the, well, wash, I mean, I kind of wiped it down, which means I need to wipe it down with something that's dry as well. Bear with me just a moment. Is Numan, I'm sorry, is Harris there? So I've got 2 people on. How many people have I got on? 3 people on. I mean, I don't know who the 3rd person is. There is like a ghost that watches all of these. And I mean, I'd love to know who that person is. I'm not necessarily even worried about that. I'm just curious. Who would watch a random GCSE? Anyway, so Harry's good to see you. Right, so your mum said it was finding the y that was a difficult bit. And I'm surprised by that because I think that's actually the easy bit. Let me show you why I think that. Justify why I said that. So suppose we did the question, one of the questions we homework was 8x minus 7y equals 30. So this gives you a chance to mark some of your homework as well. And then the other equation was 5x minus 2y, which is a hard question. Let's not mince words on that. That was a difficult question for sure. All right, it's probably one of the harder ones you can get at linear level. So there's no harm in finding it challenging. This guy gets times by 2, and this guy gets times by 7. Yeah. Okay, times by 2, times by 7. You could also times it by minus 2 and minus 7. That would do just as well. The whole point is they end up as being the same number. Yeah. Yep, times it by minus 2 and minus 7 will do exactly the same thing. Okay, and I'm going to show you that. Because if I did times this by 2, you get 16x minus 14y equals 60. And you get what? 35x minus 14y equals, what's 15 times 7? 70, 105? Yeah? So look what I've done. I've times it by 2 and 7. Because that also works. I'm just showing something slightly different. It doesn't make much difference in your mathematics. It isn't even easier. I'm just showing you that you can. So signs only matter if the signs are different. So like if that had been a minus 7 there and that had been a plus, it just works, all right? It just works. Okay? So you could have times it by minus 2 and minus 7, that would have done exactly the same thing. If you really want me to, I can go back and redo it with minus 2 and minus 7. Would you like that? Pop that in the chat box. I'll wait for you. Would you prefer if I just do it with minus 2 and minus 7? Okay, you prefer me to do that. That's fine. That's not a problem. In that case, I'll do it your way. So we're going to do times by minus 2 and minus 7 respectively. And to be fair, it might be easier for you to follow if that's what you've done. So you've got 16x minus 14y minus 16x, sorry, plus 14y equals minus 60. and you get minus 35x plus 14y equals minus 105. Right, so hopefully that makes a bit more sense to you. That's what you did. All right, no big difference. We're going to subtract them because they're both the same sign. So you end up with 19x. Let's put a minus sign there. 19x. That's going to go 0. That's going to go 45. So you've got x is 45 over 19. Let's see what you got. I'm just going to go check. Go back to WhatsApp and see what you got in my question. Yeah, you got that right. Okay, that's comfortable, right? Job done. X is 45 over 19. And you agreed with that. All right, and that's great. So what's the problem? You say y is difficult, but I say y is actually easy. It's just being good at fractions, all right? So we know that y is 45 over 19, all right? So x is 45 over 19. So let's do that. Let's put that into one of the equations. I'm going to put it into this equation. It's slightly easier to handle. So we've got 5 times 45 over 19 minus 2y equals 15. Now you've got choices here. You can either do it with a calculator, just literally straight up work out what that is. So this one minus that one divided by minus 2, that would do it. That work. I'm going to do it by hand. I want to show you how to get good with fractions. So if you've got one fraction in your question, the best thing to do is make everything over the same denominator. So 5 times 45, that's what, 225? 90, 180, 225, yeah. So that's 225 over 19 minus 38 over 19y. Now, where did that come from? That's me dividing, having the same denominator and everything. 38 divided by 19 is 2, yeah? We'll get to that in a minute. You might well be right. Now, this guy here, 15 over 9, 15 divided, and then you've got 19. What is 15 and 19 goes together? 15 times 20 would be 350. So what would that be? 335 over 19. All right? Actually, is that right? Because, no, that's definitely not right. It's over 19 for sure. 15 times 90. 15 times 20 is 300. Well, yeah, 15 times 20 is 300. It'll be 285. Sorry, my apologies. Okay? So then you subtract 225 from both sides. I'll move this down a little bit. You will subtract 225 from both sides, and that becomes minus, no, you can't see that well, minus 38 over 19y equals 60 over 19. Yeah? And then you can just cancel the 19s, and then you've got minus 38. Well, I'll move that down just a bit more so you can see it a little bit better. And that becomes minus 38y equals 60, and that's really easy to solve. Yeah, y is just going to be 60 over 38 with a minus sign. All right, and that's all there is to it. So that's how that works. If you divide through by 2, you would have got 30 over 19, not 120 over 19. So that's slightly off what you got. Unless I've made a mistake, I'm just going to run through and make sure I haven't. Don't see any. I mean, the mental math was a bit off at the beginning, but I think we were okay there. Minus 60. Yeah, I think so. I don't see any mistakes. You might want to check with the calculator, see if I'm right or not. But if I'm wrong, it's because I've got fractions wrong. I'm doing them in my head. And also, like, this is also like find your calculator. That's all the thing to do. I don't see any. I've got to say, I don't see any mistakes. That is. All right. So there you go. That's the whole working out. I'll hold it in place. I'll give you a minute to copy that one. Then we're gonna do one more for practice sake. Now remember, you could have done all of this on a calculator, right? It's good to get good at fractions, though, right? It's a skill that you're going to be using for a long time to come. Being able to deal with fractions and deal with mathematics with fractions without running to your calculator. And also, if you've got a calculator and you type the wrong number in, it's useful to have a rough idea of what the answer is going to be. All right? Because then if the calculator gives you something stupid because you mispressed the button or whatever reason, then that puts you in a position where you can understand what happened and fix it. All right? So I'll give you about another 30 seconds to get this copied down if you didn't already. So I mean, for you, you've done half the work already. You got X without any problems. It was going back into Y. And what I'm going to do is going to give you another question where you can practice the skill. Then we'll move on to the next thing if you get it right. And if you don't, it's not a good idea to move on, is it? Right. No one cares. That's not you. It's people sending me messages. I mean, it's always the people you don't want to send you messages that send you messages, isn't it? One of those things. Right, I think that's enough copying time. What I'm going to do then is I'm going to set you a question. I'm going to give you about 5 minutes to try it. Same sort of standard as this. It's probably a little easier just because those numbers were nasty. And even me, I had to kind of fumble with a few of the sums. So, okay, no harm done really. Let's pop it up here. So let's go with 5x minus 2y equals 20 and 3x plus 4, no, not 4y, 3y. Sorry, let me just clean that off. 3x plus 3y equals, do you know what? Let's go with 10 and see what happens. Should be an interesting question. All right, so you've got that one to try. I'm going to give you about 5 minutes at least just to get some of it done, if not all of it. Right, hopefully you get all of it. So you think x is 80 over 21? Cool, try finish the question if you can, then I'll take you through it, don't worry. Just, I want you to have a go at the whole thing. So your x is 80 over 21, y is 10 over 21. Let's wait for Numan to pop up and see whether he agrees with you, and then we'll go through that question together. Back in just a second. All right, Limana, have we got any thoughts on your side? Should we go through it? Let me know what you think. Formidable sneeze right there. Got confused at the last step. Okay. Again, it's the same issue, isn't it? So it's best we go through it. Best we go through it. Okay, let's deal with that. So here times by positive 3. This one gets times by minus 2. Yeah, agree with that, hopefully? If you don't, say so in the chat. Times 2 by 3, you'd get 15x. I'm going to change the pen. This is garbage. Let that pen disappear. Let's try this orange one. 15x minus, that's not bad, you know. 6y, that's far better. 60. Can you see that well? Yeah, you can. So that's done, right? The next one is minus 6x minus 6y equals minus 20. All right? They're both the same, so you're going to subtract. Yeah, we're going to subtract to cancel the y's. And what do you get? You get 21x. They cancel 80. So yeah, it's going to be x is 80 over 21. And that's done right. Where the hell did 640 come from? Well, we're going to find out in a minute, right? We'll try that in a second. So x equals 80 over 21. I'm going to put it in the 3x plus 3y equals 10, just because it's easier to deal with because everything's positive. So that's going to go 3 times x would be 240 over 21. X plus 3y equals 210 over 21. Yeah? So the answer to that is definitely a sad no. It's definitely not as big as you think it is. So have a look at that line for now. All right? So I'm going to leave that there for a minute because I'm going to have to rub it out in just a sec. So can you copy up to that line for me? For what it's worth, Harris, I think you're right. We're going to get to exactly the same place. Numan, I want you to copy this one out for me. So as soon as you copy that down, can you let me know? That's you, Numan, in the chat, so then I can finish off the question. 248 over 21x, 3y, 210. That's fine. Done, excellent. Okay, cool. Let's rub this one off here. So I'm just copying out the last line, so there's nothing new. So 240 over 21x plus 3y equals 210 over 21. And I'm just going to wipe 21. And then I'm just going to wipe the bottom off. Okay, cool. So obviously the 3y over 21 is 63. Hold a minute, yeah. I sort of think I see where you might have gone wrong, Harris, but you're not far off. So on this, we'll go pop this on the other side, and we go 3y equals minus 30 over 21. Yep, I think you've got this. So how have I done that? Subtracted, so this is not x, this is just 240 over 21. Just subtracted this from that, yeah, from the previous equation. Then divide 3 by 3, and then you get minus 10 over 21. So yeah, hats off to Harris, who got it absolutely right. Numan, do you understand? You don't understand the 210 over 21. Well, basically, it was 10 before, right? So if you had times, if you say 210 over 21, that's the same thing as 10, right? And that way we can do sums with the fractions. Everyone has the same denominator. So all I'm doing is rewriting 10 in a different form, which is the same number. 210 over divided by 21 is 10, but it's just easier for me to do sums with. So hopefully that makes a bit of sense to you. The only thing I've done with the 10 is made it in a fraction that makes my life easier. And it's always good that if you've got a fractions question, let's have every denominator being the same thing. All right? We'll do one more, because obviously we're still not completely there yet. I mean, Harris, you seem to guess it, and that's really good. Let's try one more. Let's try one more. So we've got 4x plus 6y. Oh, for flip's sake, it really gets on my nerves, this thing. I'm just trying to rub it down. It's so frustrating. Never mind, the world will not end because you're frustrated. Right down a bit. So, what was it? 6x plus 4y equals 50. What the hell is under? 3x plus 3y. So what did I say? 50, didn't I? 50, there we go. Equals 30. All right. Now you can switch up the letters on this if you're clever, but otherwise just do it the way you're comfortable doing. So the first claim is x equals 5. Yeah. No. Yeah, maybe. We'll see. I mean, do the whole question. We'll talk it through. Yeah? Might be. I haven't done the calculation myself yet. So x equals 5, y equals 5. Let's see if that's right. You end up with times that one by, well, I'm just going to double it up. 6x, 6y, 10. So that means, yeah, that's right. That's fine. So let's do one with fractions in it, because I think that one worked out a little too nicely. So 5x plus 4y equals 24. 3x plus 6y equals 22. That definitely will give you fractions. That's the last one we're doing. If you get this right, we'll stop doing like the ones like this and move on. So do both of them, and we'll see whether what's right and what's not. Yep. Harrison, 56 over 18 is right. 28 over 9 is the simplified version. That's good. And you should simplify where you can. All right. If you do that, your sums will generally be easier. Yeah. So where possible, simplify. So if you get the 56 over 18 is x, x is 28 over 9, that's much easier to handle. All your denominators will be 9. The only thing you're multiplying by through is 9 as well. So good shout. Well done, Harris. So 19 over 9. Yep, 19 over 9. Let's do it together and check whether you're right or not. So what you're going to do, knowing you would have times this guy by 6 and that guy by 4. Yeah? I'm guessing. And that's nothing wrong with that, because that's what you did. 30x plus 24y equals, what the hell is 24 times 6? It'd be 12 times 12, wouldn't it be 144? The other one, that's 88. 88. World famous symbol for Heil Hitler. That's 12x. Right, there we go. Lovely. So, yeah, I hope you agree with that. Yeah? Yeah. Good. I'm glad we agree. What does that give you? Subtraction, 18 over 18x. That gives you what? 1256? Which almost works, doesn't it? It's almost 3, but it isn't. It isn't 3. So 56 over 18, which quite rightly, Harry's got down to 28 over 9. It's beautiful. All right, cool. So that's that bit done. Now what we're going to do is we're going to lob it into the easier of the two equations, which is the 3x one. that'll give you 3 times 28 over 9 is what? It would be 84. So that's 84 over 9 plus 6y. 22 times 9. 20 times 9 is 180, 198 over 9. So put it on the other side. I'll move this down so you can see it a little bit better. Sort that out. You've got 114 over 6. Well, 114 over 9. So 6y equals 114 over 9. So then you divide through by 6. It's 114 over 56. And that probably does tidy itself up all right. Does it? Well, we'll find out in a minute. This is definitely true. So how does that tidy up? Definitely by 2. I'm just going to do the working out under here, and I'll get back to you on this. 114 over 56 definitely goes by 2, so that's going to be what, 57 over 28. Yeah, that's right. I've got 57 over 28. Do they both go by 3? That's an interesting thought, isn't it? You've got 9 times. That's 54, of course. I'm being stupid. So that's going to be what, 27? Yeah, then divided by 3. Yeah, it's 19 over 9. You got it. Well done. Good job. Right. Let's try something new. Try something new. We've got about 25 minutes of this lesson to go. So I'm going to show you something completely different. I mean, it's not completely different. It's the same simultaneous equations. But now it's going to be what the title of this video was, which is simultaneous, linear, and quadratic. All right? So we're doing simultaneous, linear, and quadratic. So here's an example. Suppose you had y equals, oh, for flip's sakes. Oh, so annoying. All right, that's better. I suppose we had y equals 3x plus 1. It's a slightly different style. And you've got x squared plus 4x plus 3 equals y. All right? And the question is asking is, do these lines meet? Or solve the simultaneous equations. They both mean the same thing. Because where the lines meet is where the solution to the simultaneous equations are. So if someone asks you, do these two lines meet? They're basically saying, solve these as simultaneous equations and see if you get any answers. All right? And I'm going to show you a few tricks to this. What I need you to do is write down what's going on. So your title is Simultaneous Equations, Linear and Quadratic. It's a completely new title. And this is a whole step up now, yeah? You'll find this is quite different to anything you've done before because it's going to bring in a lot of stuff that you've learned. I'll move the camera down. I know you can't see that. So here's your title. So there's your title, Simultaneous Equations, Linear and Quadratic. And then what we're going to do is we're going to find out the solutions to 2 simultaneous equations, one of which is linear, one of it's quadratic, but always bearing in mind that an equation has always got a graph, which is its picture, and we can also think about it in terms of graphs as well, okay? So it's not just an algebraic exercise. I want you to think about it as a graph exercise as well. So as we go through it, that'll make more sense to you. But for now, I'm going to give you a couple of minutes. Can you copy that down for me? Wow. Let's see what's happening to that. That's just falling off the edge. That has. Let's have a look. Look at that straight. There we go. It's almost right. What are you seeing? What are you? So you're seeing that. Of course, that's too far up. There we go. All right. Cool. Had a bit of fun there. Try to do some applied gymnastics with the camera. There we go. So copy that for me and copy the question with the wording. All right. As soon as you've done, let me know. I'll be back in just a moment. Can't see top line. Top line is y equals 3x plus 1. Y equals 3x plus 1. Okay, brilliant. All right, let's get started, shall we? So you know what the question was. I'm going to bring the camera so you can see it. So what have we got here? We've got ourselves two equations that, for God's sake, let's do something about this. Possibly push it up a bit. Yeah, we're good. Good. That's mostly competent. Right, lovely. What have we got? So these two equations here, yeah? And we know what y equals 3x plus 1 look like. It'll look like a straight line. And we know that a quadratic is either going to be a smiley face or a sad face. And it's going to be a smiley face because it's an x squared, right? So there's three different ways those two things could interact. Okay? You could have this, where the line cuts the curve in two places. You could have this, where the line just brushes the curve, touches only once. Or you could have this, where the line and the curve miss. All right? So those are three separate things. What does that got to do with the simultaneous equations? The three different graphs will tell you how many solutions you've got. So if you drew the picture of this and you drew the picture of this and they joined up, yeah, you drew the pictures of them, where would they meet? If the simultaneous equations had two solutions, the graphs would meet in two places. If the simultaneous equations have one solution, then if you drew the picture of them, the graphs would only touch once. And if the graphs did never meet at all, yeah, then you know that the simultaneous equations have no solutions. So the number of solutions of the simultaneous equations and the number of times the curve and the line meets, if you draw them, are the same thing, okay? 2, 1, 0. Can you write that down as notes for me? So the number of times that the curve and the line meets, if you draw them, is the same number of times that you'd have a solution. Yeah, you'd have two solutions, one solution, and no solutions. So what you need to be doing is copying it. Not copying it, just writing down notes, actually. Writing down notes that explain to yourself that the number of times a curve intersects with a line is the same number of times that the two, if you drew, that's those two things, you drew them, the amount of times that when you draw them, they cut each other is the same number of times that you're going to get solutions. So for these simultaneous equations, you could either have two solutions, one solution, or no solutions. All right, and we'll demonstrate that in just a moment. Done? Excellent. All right, let's roll. So we still got this question in front of us. Let's have a look. And let's try and solve these simultaneously. Yeah. So here we've got quite a simple example. We've got y equals this and we've got y equals that. So that means if they're both equal y, they're both equal each other. So we can turn this equation and this equation into the following equation: x squared plus 4x plus 3 equals 3x plus 1. All right. So if they're both equal to the same thing, they're both equal to each other. Yeah. Because y and y are equal. Yeah. The next thing we're going to do is remember the idea that you can't solve equations. You can't solve equations, quadratic equations specifically, unless if they equal 0. So what I'm going to do is I'm going to take away 3x plus 1 from both sides. So here we're going to take a 3x, going to take a minus 1, going to take a 3x, going to take a minus 1. All right. And if you do that, you get x squared plus x plus 2 equals 0. And that's now in a form you can solve. All right. So I want you to copy that for me. And then I want you to solve that equation if it solves. Okay. I'm going to solve that equation for me. You can use whatever method you like and tell me if it solves or not, because you might not. In fact, it doesn't. But how would you know? In fact, stop there. Copy up there and then say done. Then I'll show you how to tell whether an equation solves or not. In fact, you might know it already. Okay. So you got a quadratic equation. How do you know if it even solves or not? You can use something called the discriminant. So again, this is a new heading in your notes. The discriminant is what tells you whether a quadratic equation will solve or not. All right? And the discriminant is b squared minus 4ac. And you've seen that before. All right? You've definitely seen that before. It's part of the quadratic formula. All right? And the rule is that if you get your b squared minus 4ac, nope, just the b squared minus 4ac, my dude. If you get your b squared minus 4ac and it's greater than 0, then you've got two solutions. If it equals 0, you've got, some people call it one solution, which is what I do. And some other people say there's two equal solutions. But I like one solution because I think you've got two equal solutions, you've got one solution, all right? But beware that other people say other things and it's fine. We can handle it if it comes up. If it's less than 0, it's less than 0, there are no real solutions. All right? And the word real will never be a problem to you unless you do A-level further maths. All right? So what I want you to do now is I want you to do b squared minus 4ac, just b squared minus 4ac for this guy, and tell me whether you get a positive number, 0, or a negative number. Okay? So just do b squared minus 4ac, tell me whether you get a positive number, a negative number, or no number at all. As soon as you've done that, can you pop that in the chat for me? So you've got minus 6, and I agree with you, is minus 6. The b squared is 1, 4ac's is 6, did you say? I got that as 7. I got it as minus 7. B squared is 1. 1 minus 4 times... No, yeah, you're wrong. It is minus 7. My dudes. B squared, 1 squared is 1, minus 4 times 1 times 2. That's minus 7. Correct. Well done. We're getting somewhere. Anyways, it's a minus number, whatever the hell it is, right? So what does that tell you? That means that that quadratic has no solutions, which means the simultaneous equation has no solutions, which means these two graphs will never meet. All right? Let's go through that chain of causation again. You may need to watch this part of the video again later for your homework, all right? We proved from the discriminant that there's no solution to this quadratic equation. But this quadratic equation was made out of these two equations. So that means there's no solution to this simultaneous equation here. There isn't one. All right? There isn't one. And if there's no solution to those two simultaneous equations, the line y equals 3x plus 1 and the quadratic curve y equals x squared plus 4x plus 3 never meet. There are no intersections there at all. Okay? So you've got a minute to copy that down for me. If you haven't copied down already, write down a quick explanation. Got a minute and a half. Explain, write down in your notes an explanation of how that works. The discriminant of the quadratic told me there's no solution to the quadratic. So if there's no, the quadratic came from the simultaneous equations. So there's no solution from the simultaneous equations either. But if there's no solution to the simultaneous equations, then there isn't a intersection between the two curves. And that's that. You've got like maybe about 7 or 8 more minutes on this. So what we're going to do is do one more example. We're not going to actually solve them today. I don't think we're going to get to that point. What we might do is just be able to say, can we work out if there is an equation or not? I mean, whether there are solutions or not, sorry. Okay, brilliant. You've got that, Quadratic. Nice one. All right. I'll rub out the top bit. And we'll do the next one stage by stage together. Okay, so you're going to do bits and bobs on this. Put the camera up to the right height. Right, okay, so your first equation is going to go y equals 2x minus 1. And you can't see any of that, so I'll just move the camera up a teensy bit more. Very cool. And then your second equation is going to be y equals x squared plus 3x minus 1. Okay? And what I'm going to ask you to do is decide whether this thing has got solutions or not. So step number 1 is you've got to put the equations equal to each other. Could you do that for me now? Put those two equations equal to each other and write it in the chat box. So we're going to do this step by step. We'll do it together. So as soon as you equated those two equations, could you write it down in the chat box for me? Right, so the claim is going to be x squared plus x minus, well, I'm not sure about that. I would have got x squared plus 3x minus 1 equals 2x minus 1. Cancel the 2x minus 1 would say subtract 2x but add 1. Subtract 2x and add 1. Remember, the whole point is to make it equal 0. So to get rid of 2x minus 1, you need to take away 2x, but you need to add a 1. So that gives you x squared plus x plus 0 equals 0. I mean, you don't need the plus 0 there. I'm just doing it to make the point. So yeah, that's what I would have got. X squared plus x equals 0. Now, the question I'm next going to ask you is, how many solutions has it got? Can you find out using the discriminant? So use b squared minus 4ac and decide how many solutions has this thing got. So 2 minus 0. So you've got b squared is 1. Where are you getting 2 from? Where is 2 coming from? Are you under the illusion that 1 squared is 2? Because really not. 1 times 1 has never been 2. Yeah, so it's 1. So it's a positive whole number. So how many solutions has it got? Two solutions, absolutely. Well done. Right. Okay, so I'm going to set you homework for today now. And we're done here. So here's your homework. 2 simultaneous equations to solve. which is the normal simultaneous equations, the ones you're used to. And then I'm going to ask you to see how many solutions these quadratic equations have got. So the simultaneous equations are 3x minus 2y equals 10, 2x plus 6y is 8, 5x minus y is 15, and 3x plus 2y is 40. All right, so we've got two equations there for you to do. And your other ones are how many solutions? So you've got to tell me how many solutions, right? And that's going to be using the discriminant. And that's, so we do 3x squared plus 6x plus 1 equals 0. That's question number 1. And question number 2 is 2x squared plus 11x minus 7 equals 0. So that's literally all the work you're going to be doing today. So that's it. Nothing else. Nothing more, nothing else. Nice and easy. All right. So I hope that makes sense to you, so you all know what you're doing. That's your two simultaneous questions. That's a question asking how many solutions, and you're meant to be using b squared minus 4ac. All right? And that's that. As soon as you copy that, you're free to go. So if you copy that homework, I'll be massively grateful. Done. Okay. In that case, have a lovely day. If you've got a copy, I reckon Harris will have it copied as well. Just give it a few more seconds so you can. No need to rush. Okay, give you another minute or so. If you finish copying, just put in the chat box and I'll close down the call. And I'll close down the YouTube. So if you finish copying, just pop that, say that you've done it. All right.